Now this slide shows the mapping between the logical and the transport channels for the downlink and for the uplink, which is defined for LTE. The mapping actually takes place inside the MAC layer, medium access control. So you see here the logical channels listed. For the downlink, that's the paging control channel, which is mapped onto the transport channel, the PCH, the paging channel. We have a broadcast control channel that can be mapped on broadcast channel or downlink shared channel. We have a common control channel, dedicated control channel, and dedicated traffic channel as logical channels defined in the downlink, which are all mapped on downlink shared channel. So you see here the downlink shared channel as a transport channel in LTE has a very important function.
Christina, one question to that slide showing the downlink channel mapping. You just explained that the broadcast control channel can be either mapped to the broadcast channel or to the downlink shared channel. How that can be understood?
Yeah, sure. So the broadcast control channel actually can consist of different or can carry different types of information. The master information block is actually mapped on the broadcast channel, which is then mapped onto the physical broadcast channel. And the other types of system information are actually mapped onto the downlink shared channel. On the uplink side, we also have the picture here. So that's showing that common control channel, dedicated control channel, and dedicated traffic channel as logical channels are mapped onto uplink shared channel. And there's also a random access channel defined as an uplink transport channel. Now, these pictures are also illustrating that the protocol architecture for LTE was significantly simplified. And this especially becomes very visible when you compare to wideband CDMA HSPA and the logical and transport channels that are defined there and the mapping in between. So you see in LTE there was a reduction in channels that were defined to simplify the handling and to simplify the structure of the protocol architecture. Now, these tables show the LTE UE categories, terminal categories for downlink and uplink that are specified for LTE. The upper table is for downlink. 5 UE categories are defined in downlink, and they, for example, differ in the maximum number of bits, downlink shared channel transport block bits, that can be received in a 1 millisecond transmission time interval. That's the leftmost column here. So this column and these values also determine the actual peak downlink data rates that can be supported by a certain UE category. For example, if a UE of category 4 is able to receive around 150,000 bits in 1 millisecond TTI, this translates into a 150 megabit per second peak data rate. Another interesting criteria of the UE categories is the MIMO capability, the multi-antenna capability. All terminals in LTE mandatorily have 2 receive antennas, at least. But the first category, the UE category 1, does not support transmission on multiple layers. So it does not support a real spatial multiplexing, a real dual stream transmission. This is only possible from UE category 2 onwards, so categories 2 to 4 support a 2x2 MIMO setup with dual stream transmission, enabling the higher data rates in LTE. Category 5 even supports a 4x4 MIMO setup because these UEs of category 5 would have 4 receive antennas, and they can then of course also support corresponding data rates of up to 300 megabit per second. Again, these is theoretical values which you would not see in a real system, because in a real system you have to consider cell load and radio link situation, which would in reality reduce the data rates that can be seen by a certain UE. The lower table shows the uplink UE categories. Again, there's 5 of it, and again they differ in terms of the maximum number of uplink shared channel transport bits that can be received within a 1 millisecond transmission time interval. And the highest category here supports 75,000 bits corresponding to 75 megabit per second peak uplink data rate. The reason for this is that 64 QAM modulation scheme is optional for the terminals in the uplink, so only the category 5 supports 64 QAM and can therefore support this high data rate value.
Christina, one question to the UE categories. Do we know on which categories the wireless industry is working on? So means which type of UEs we will see when LTE is commercially rolled out?
Yeah, of course. So for the downlink side, of course, 4 receive antennas at the terminal is very ambitious. So we won't see that in the near future. But having 2 antennas at the terminal and supporting the true MIMO spatial multiplexing, that's definitely coming. So we will probably see UE category 4 in downlink, definitely coming. Also for the uplink, the highest category is probably quite ambitious, supporting the 64 QAM. So we will see the other categories initially.